Everyone, thanks for sticking it out all the way through to the end of the day. Anyone already brain dead? The bad news is I am already brain dead, and this is a pretty heavy session, so I hope to survive. Thanks for coming. There are so many other good sessions going on right now, so I particularly appreciate it that you've chosen to come and spend it with me. Hopefully we'll have time for questions, but I can say with certainty that this is a packed session. There is a lot of information in here. And so I believe I'm being optimistic if I can get through everything with time to spare for questions. So not sure about that. I'll try to go quickly so that we can manage the time well. So if you ask a question, I'm not discouraging you from asking questions as we go along, but if you do ask a question, I may have to say something like, why don't we hold that till the end and then I can answer that offline, just so that we can stay on time, okay? Also, hopefully you've taken a moment and checked the program, and so you are aware that this is a high-level session. So if it turns out that you need some help understanding some of the basics that underlie many of the principles that I'm going to explain, I have bad news. There really is not time for me to explain those concepts. So hopefully you've done your homework or you've had experience in your job that you feel well prepared for this session, and so it will help you to get over that initial hurdle of knowing many of the basic things that I'm talking about today. And I have bad news. I actually realized that I have left the old subtitle for the session I did yesterday under there. So we're not going to talk about ideas that win executive support. That was yesterday's session. So, hey, there's nothing like making a mistake in the first 3 minutes of your presentation. Right on, representing for my peeps. Okay, so here's the boilerplate. Don't forget to silence your phones. Be a good neighbor. Don't go to your favorite humor website and start cracking up so everybody's looking at you. I thought you were on call. It's like, no, I'm reading the comics. Yeah, and then also keep in mind, PASS is commonly thought of as this great conference. The biggest SQL Server related conference in the country, in the world. And so that's what a lot of us think of when we think of PASS. But PASS is actually the professional association for our discipline, just like the American Medical Association is for doctors in the United States. And so it's a lot more than just a conference. There's the 24 hours of PASS marathon sessions. There's the local user groups, which hopefully you are active and engaged and involved in. There's the virtual chapters, also called virtual groups. So if you have an interest in something like high performance, there is a virtual group for high performance SQL Server. There's one for French speakers, there's one for Hebrew speakers, and so forth. And then there's also the other activities that you can get involved with, like SQL Saturdays and things like that. A lot of great stuff going on in our professional association. Also, I do want to say, please take a minute. I'd love to hear your feedback. And this is a session that every time I've presented it, I've gotten great feedback and gone back and changed it a bit. So I'd love to hear what you think and if this is resonating with you and was valuable to you, and if there was something I could have done to even enhance that value even more. As well, don't forget, you can also give feedback about the conference to the conference organizers, to PASS. So take advantage of that. Every one of these submissions gets read. So if you have something that's on your heart, let them know. Okay, so with that, who am I? In case we've never met before, my name is Kevin Kline. I'm a principal program manager for Century One. Come down and talk to us in the exhibit hall. I was one of the original 9 founders of PASS. One of only 3 people in that group that is still really active in the SQL Server community. If you're curious, the other 2 are Kaylin Delaney and Brian Moran. And so I was one of the founders and an early president of the organization. I read a lot of books. My best known book is SQL in a Nutshell. And I get a lot of grief from my friends that I have this ridiculously large family. I have 1 son who's 26 and 6 daughters afterwards, so we call them the Horde. And so I tell you, with 6 daughters, we just get a lot of eye rolling in the house. Dad, God. Okay, So that's a little bit about me. A few things about this session. I want to give props to the people who inspired me and gave me guidance and direction. Those are people like Brian Hansen, and I encourage you to read his Twitter feed, to look at his website. He gave me a lot of the impetus to get going on this. Other people like Rob Volk, Paul White, and Benjamin Navarez have written extensively on these topics, and so they contributed as well to this. So I stand on the shoulders of giants. That's what enables me to look so far into the distance, right? A couple things about this session. It's not just a regular performance tuning session. You already know how to do typical performance tuning. That's why it's as high level as it is. You already know how to read an execution plan. You know what set statistics IO on is. You know what set statistics time on is. You don't need me to explain that stuff, and I'm not gonna. But what you do wonder is, I know SQL Server could have chosen between several different join algorithms here for this. Why did it choose a hash join rather than a nested loop join? It had a lot of alternatives. Why did it choose this one? I'm going to show you the secret undocumented trace flags that tells you what SQL Server was considering when it went through this process, okay? And when you know those kind of things, you can do some really cool stuff later on down the line in the way you write your code, because you understand the fundamentals. And I mean beyond fundamentals. Like you are a farmer, but not only do you understand fertilizer and water and seed, but you understand the chemical balance of the soil, right? And acidity versus pH, versus nitrates and phosphates and stuff. So you know more than just those high-level images. You are going to learn some really, really deep things about how the optimizer works. And that's cool. All right, so what's our agenda? I'm going to take us through several kind of, big milestones as we go through this. And I have several sets of demos that we're going to do as well. All of the scripts are already posted. Well, at least I've already put them up with Pass. I'm going to give you another way to get the slides and scripts as well at the end. So they're all posted. There's two main scripts that we'll be using and you can reuse in the future, as well as the slides as well, okay? So we'll walk through the whole query execution process, and as we go along, I'll show you some different queries you can use for telemetry to find out what is happening with those, and I'll also show you a lot of these different trace flags. And as we look at these trace flags, we'll explore things like the heuristics that SQL Server uses to do the different kinds of analysis and consideration of which execution plans that it wants to choose from when it does the work that you request of it, okay? All right, so right there in the title of the session is Optimizer Secrets. So why don't we start with a secret? A lot of people don't realize this. So let me show you a couple SQL statements that you may never have heard of before, and they're kind of fun and they're interesting. And these also impact some of the stuff that will come up later in the presentation. So let me actually flip over here to Management Studio. And I'm going to drop this. Hopefully it's going to work okay. Folks in the back, is this legible? Can you see that? Okay. Oh, awesome. I can't see it, and I'm standing right next to it. Thank goodness they have these monitors right here in front of me. So here's one thing I didn't know actually even until recently. Here's a trace flag, 2588. And when you turn that on, now if you execute this statement right here below it, dbcc help, and you say dbcc help ? Or you put anything else in there that is a documented statement, a dbcc statement. So if you said dbcc check alloc, for example, and you executed that, it'll tell you all of the different statements that exist for, let's actually do that. We'll change this one to check alloc, okay? So check allocations. Now when I say dbcc help, it will tell me all of the switches for that dbcc statement. But with this undocumented trace flag right here, we turn this on, and then we say dbcc help, and guess what? it shows us all kinds of undocumented DBC statements that are available in this version of SQL Server, right? So in SQL Server 2012, my favorite one that appears in this list is DBCC crash DB. Doesn't that sound like fun? I'm going to put that into one of my SSIS packages, the ones where I want to just not come into work on Monday, right? So yeah, how about we try one of these that maybe we're not familiar with? You saw that I had cut and replaced it a minute ago. So let's put in DBCC Autopilot. Now you may not have heard of Autopilot, and of course, as I mentioned, it is not documented, but what happens now when we put this in is that at least you now know what are the parameters that it will accept, and from that you can kind of get an idea of what it is about and the kind of information it's going to return to you. Now again, not all of these are guaranteed to be safe to run in production. So don't call me if things go sideways, especially if you're running that crash DB. But but there's some that only appear for specific versions. I've listed out some of those here for you, and SQL Server 2014, for example, and it makes sense. What was introduced in SQL 2014 that might cause there to be this undocumented flush query store? The query store, right? So there's this new thing called the query store, and it takes a certain reservation in the SQL Server buffer cache. And so you know what? What if I want to clear that out all at once? Well, there's an undocumented DBC statement that allows you to do that. Is that new to anybody here? Right on, okay. So I can check at least one thing off of the things I promised you in the abstract that we'd see some secrets here. All right, now the next one I want to tell you about is called DBCC Rule On and Rule Off. So one of the things that happens inside of SQL Server is there are all of these, well, it's actually the crown jewels of a relational database is the cost optimizer engine. You know, if you talk to the designers of MySQL or the designers of Oracle or PostgreSQL or any of those relational databases, they would tell you that cost optimizer, the query processor and optimizer, that's the crown jewels of this database system. And so we have a situation here in SQL Server where there's all kinds of these algorithms that it uses behind the scenes to choose different kinds of execution plans. And it does this extremely fast and very effectively. And most of that's not exposed to us, but we can actually take a look at it here. So what we can do is we can turn on trace flag 3604, okay? That's a documented trace flag, by the way. What does it do? Anyone know? It shows the output of DBCC, exactly right. It shows the output of DBCC to the client. Otherwise, you won't see it. So you gotta do that if you wanna see these great results. Now, let's execute this command here, DBCC show rules on. And this pretty much works in all the recent releases of SQL Server. And so now what we're seeing here, if we look down in the results set, is various internal names for the algorithms that SQL Server uses, the heuristics it uses for choosing execution plans. So anyone want to hazard a guess what JN to NL means? Join to nested loop, right? So we have LOJ to NL. Left outer join, right, right on. You guys are right there with me. Now, one of the things that we probably won't have full time to do is to look at all of these and explain them. But in the scripts that I have, I take you through a particular SQL statement that starts very simple, and then we add a where clause and a join and group by and so forth. And some of the DBC statements I'll show you will expose all of the different algorithms that it's looking at here. And so it's pretty easy to go through a 10 or 15-minute exercise to run all these different variations of a query, and then you see how it starts to reveal what the names are of these specific behaviors that it's invoking. Does that make sense? Yeah? So it's kind of like when a psychiatrist says, well, clearly they have body dysmorphia, with shades of this and such, and you're like, well, what does that mean? And you're like, well, it just means they're crazy, right? So that's what this is saying. We see a where clause, It says, well, what is this really, what is it behind the scenes? And then they come up with the actual specific psychological term. In this case, it might say that where clause is some kind of equality operator, logical operation, equality comparison. So that's how you suss this out. You have to do a little bit of troubleshooting or a little bit of working around, tinkering around with these queries, and then you'll see all of the different permutations of those operators as they come up. All right, so just another thought too about what happens behind the scenes. One of the weird things I often roll around in my head when I'm in the shower. Does anyone else have your best ideas while you're ruminating in the shower? It's just me. Oh, okay, all right. And now, okay, some of you are with me on this. Is that people designed this language, right? That means they had conscious choices they could make about how this works. And I don't know why they just didn't do it in the simplest way. They changed all kinds of things around. So like one of the things we see when and we'll come back to this example, I'll use this one a lot, is that the relational database doesn't process a query the way we do. For example, have you ever just wondered aloud, why do we declare the columns first before we've declared what table it comes from? Why don't we just say, from the users table, I want these columns, right? Well, this is actually what SQL Server sees internally, right? When we say select from where and join, this is the order in which SQL Server sees and processes our requests. And that comes up as we look deeper into this. You'll see behind the scenes that certain things start to happen out of the order that we've been taught to write a SQL statement. It's not rocket science or anything like that, but it is important to know that SQL Server, and in fact all the relational databases, process these things, parse these in a way that's a little counter to the way we speak in everyday language, okay? So, what we're going to do now is I'm going to walk through kind of a deeper level dive into what the query processor does. Now notice I've got two different terms here. I've got the query process, or the query processing set of activities, and then we have the query optimization set of activities. Query processing is a superset of the query optimizer. Believe it or not, SQL Server can do a lot of query processing without even having to engage the optimizer. Those are called trivial plans, right? So you probably have heard of those before. So this is our step-by-step process, and we're going to walk through these as we go along. All right? So the first thing we're going to talk about is parsing and binding. Parsing is a fancy word for, the root word means to cut up. Right, to chop up into its components. And some of us who are a little bit older, who have a little gray hair, you might remember sentence diagramming. Who's with me on this one? Remember that? They don't teach that anymore in school. And I'm like, get off of my lawn, you stupid teenagers. It's like, you need to know how to, cut the verb out from the noun and the modifier and all that stuff. That's what the parser does. If you had typed in SEELCT, it would throw a parsing error, right? Because it says, hey, I don't know what select is, but I do know what select is. So the parser goes through not just the cutting up of the language and making sure that this is a valid SQL statement, it actually does quite a bit of deeper stuff. For example, yes, it does validate the correct syntax, but it also looks to see if any of the columns that you're referencing, if they have constraints on them, right? It also looks at, maybe there's a view under there. So if you've selected from a view, it has to turn that into a query and instantiate that and get that result set, get that plan. And then it builds something called the initial parse tree, okay? Now this is different than the word tree comes up a lot, and we'll have an initial memo, and we have intermediate memos, and we have a final memo. We're going to spend a lot of time on the memo structure. But in this case, it builds the initial parse tree. And the thing to remember about the the logical parse tree is this is the objects that SQL Server is going to reference. It needs to know as quickly as it can figure these things out, what you want to reference. And then in the very next step, right after this, what it does is it goes through the binding process. Now, the binding process is, again, a very deep, very fast, almost instantaneous process. It takes a moment and makes sure that the objects you're asking for exist. And it says, do you have permissions to those? Yeah, they might exist, but you're not allowed to touch those. It does some other things like aggregate bindings and associating aliases, for example. And this is an interesting and important one. I won't have time to demo this, but it generates a hash based on the query text. This is really, really important to your plan cache, right? So your cache can fill up with different objects over time. But if I've written a query that's exactly the same as a query that you have written, except I used all uppercase and you used mixed case, will SQL Server find a cache match when it looks to see if it exists in the cache? It won't. Believe it or not, I mean, it's the exact same language. Or if I was typing a little bit fast and sloppy and I fat-fingered it and there was 2 spaces instead of 1, your query is just like mine, except that I have 2 spaces between from and the table name. It will not find that match because it takes a hash of the binary values. And a binary uppercase S is not the same as a binary lowercase s, right? So keep that in mind. That's why you need naming standards and coding standards. You don't have to choose mine, even though they're correct, but you have to choose somebody's naming standards, and you really need to stick to it as a team, okay? So these are, and one other quick note too. When we're working on ad hoc batches, SQL Server is doing that name resolution, make sure the table exists. Guess what it doesn't do in stored procedures? It doesn't check for name resolution when you compile your stored procedures. So that means, the reason for that is, what if you are in your stored procedure, you say create temp table, hashtag my temp table, and you reference that temp table later on in your stored procedure. So it makes sense that a stored procedure wouldn't require a table to exist to compile properly. But what that means is when you execute that stored procedure, it will fail, okay? That daemon inside the code is called deferred name resolution. We defer it until execution time, and it causes a lot of people to trip and stumble on that. So just to go a little bit deeper on parse trees, again, don't forget, here's what our query looks like, and then here's what your parse tree would look like in a situation like this. It's the internal representation of those logical, now keep that in mind, logical query operators. It hasn't chosen any physical implementation of the operations yet. It's just saying I need an outer join. It hasn't decided whether that's going to be a hash or a merge or a nested loop. It's just said I know I need an outer join. And so SQL Server will go through, it decides to order all of these. Oh, also keep in mind that, again, some of these are special kind of academic words. So when we see the term select appear in this logical parse tree, that doesn't mean a select statement. What that means is filter, actually. So it's much more like a where. And then in other cases, you'll see the word project. And that's a relational algebra term that means select, but it means select a single column. So you'll see project, and it'll give a list of the different column names. So when you see that one, beware of the nomenclature there. So let me show you a little bit in some demos what is going on at this stage of the process. All right. Oh, and one of the other things, too, that I was going to show you is with the show rules on, show rules off, you can actually go into SQL Server, and then you can say rule on and rule off. You could actually say, you know what I want to do? I want to turn my join to a sort merge and my join to a hash sort. I want to turn those off. Actually, it's April 1st. The DBA is away from his desk, and he didn't lock his his management studio like he's supposed to. So I'm just going to sit down and pencil this in real quick and execute this while he's away. And then suddenly all of his joins are just broken everywhere. So yeah, shame on that DBA, right? So I first heard about this from Rob Volk in the context of, pulling shenanigans on one of your coworkers. But this can also be really, really valuable for when you're doing some really deep query tuning and you want the SQL Server to show you other alternatives, but maybe you're not allowed to alter the code because you bought it from a vendor, and so they don't want you to put in a hint or something like that. So you could actually go through and make sure that it's not going to do a particular action. You've eliminated that from the list of things it can do, and then you can come back to the vendor and say, hey, I really need for you to add a with and a hint on this and make it do a hash or a hash join on this rather than the nested loop that it does by default. So this is a great way for you to do some testing on these. So I have a little example here of how we can try that, turn off different of those heuristic operations or re-enable them later on. So talking about parsing and binding, I'm going to go to the CorpDB database. And in case you didn't know about it, there is this interesting little statement where we can tell SQL Server to only parse. So we'll prevent it from going further into the optimization process by enabling that. So when we execute a particular statement, it's going all the way through parsing and binding, and we can see that this clearly, it works, right? On the other hand, I don't have this table right here. I don't have this column. And if we execute that one, it hasn't done anything yet. It hasn't collected any statistics or any things like that, but it parses fine. That's because it's actually not binding all the way back to the table yet. It's just made sure at this stage that, that your SQL syntax is correct. All right, I'll turn that off. Now, there's another statement that you might not be aware of. Many of you are advanced, and so you do know this, is to say format only. And this takes it not just to parsing, it takes it through parsing and binding, okay? It won't be fully optimized, won't go through the query processor, but it will do the binding step, which the previous one didn't. And when we do this, it will tell us a bit more information. So, for example, if I now do this one, remember one of the one of the steps in the binding is that it looks to see if you have permissions to the objects and the objects exist. So we've looked at parsing, which gives us the SQL. Now we've gone to the binding step, and we see, okay, this is the step at which SQL Server actually goes back and says, does this object exist? Do you have access to it? And so forth. So let's turn that formatting off. Now, some of the other things that happen in parsing and binding. For example, data type resolution, all right? So here we've got a join where we've got customer ID and order ID. Even though the column names and so forth are different, this is going to work just fine because same data type, right? That's okay. I can parse that just fine. I can bind that just fine. But what if we have different data types? It's at the binding stage that SQL Server actually says, you know what? That doesn't work for me. So this has actually failed. We get this error message before it's even gone to the query optimizer. That's the main lesson I want to show here. If you have a parsing and binding problem, it doesn't even spend cycles on that. And that's a good thing. All right. And so, again, with aggregates, for example, is another way that we might see the parser and binder kick into action here before it even gets to the query optimizer. All right? So what's wrong here? It generates an error during the binding process because the first name isn't a valid column, right? You have to list in your group by all of the columns that aren't the aggregates. So it's the parser and the binder where we're seeing these particular problems surface rather than all the way in the query. I didn't really think about that much. I just thought SQL magically, sprinkled its unicorn dust and said, here, you've got an error. But it actually does it in specific phases as it goes along through the query processing. All right, so that's That's the first two phases. This happens almost instantaneously, super fast processing. Then there are the next couple stages. And one of the things that's really interesting about the next couple stages, we've gone through parsing, we've gone through binding. Next phase is something called simplification. And then that is also followed by the very simplest kinds of queries that can be solved either only one way or very, very obviously only one good way. So SQL Server might say, oh, well, I have more than one way to solve this query, but I really only have one good way to solve this query. That's a trivial plan. And the interesting thing about that is that SQL Server doesn't really even load up the metadata. And when I say metadata, I'm talking about things like the statistics. I'm talking about, looking at the data itself. It doesn't go to the costing engine and figure out what the cost of any of these things are. It just says, oh, this is so simple. There's only one way to do this. I don't even need to know what the selectivity is on the indexes or anything like that. So all it needs is the database schema, basically, and the query. And it's able to go through these 4 steps. Yes, question? Yes? Yes? So in this, I believe your question is, I have top appearing right here. And so why is that appearing right here? What happens is SQL Server, as it goes through this process, it knows it's going to filter to the top 5 rows here. And so when it builds, that's one of the ironies. Again, if we go back a little further here, and we look at the query, in fact, let me go back just a bit further to what SQL Server sees. Again, this is what we write, but if we reorder this, what we see SQL Server is parsing out is from, then the joins, then the join conditions, then the filter, group by having, and then finally the select, order by, and then top. But when it builds the parse tree, it actually puts that at the beginning of the parse tree. It doesn't change what your result is. That's just the way that SQL Server internally decides to arrange that inside of the parse tree. All right, so let me move on here. Now, simplification. Simplification is one of many, many things inside the query optimizer that are designed to make this go fast. And when I look at some of the, say for example, the stuff that Bob Ward showed in the keynote and also in the session before this one, where they're looking at a 7 terabyte database and they get results back in 0.6 seconds. I'm really just flabbergasted by how fast that really is when you think about the amount of processing and the number of decisions that SQL Server could choose between, that it actually gives us a result set like that. And simplification is one of the key steps to making those queries go really, really fast. So what happens in the simplification phase is it does things like, I remember at a time at SQL 2000, for example, SQL Server didn't always convert subqueries to joins. Even if you had a correlated subquery, that was one of the performance tuning things you could do. You could rewrite your subqueries as joins, and you might get better performance. Now SQL Server doesn't need you to do that because it basically takes all subqueries behind the scenes and rewrites them as joins to see if that performs better. It may convert inner joins to outer joins. It looks for situations in which there may be redundant joins that appear in an outer query and then also in a subquery, and maybe I can get rid of those. Contradiction detection is also another clever little trick that it does. So let me show you a little bit about this. Okay. So the first thing is that idea of a trivial plan. SQL Server has figured out that there is a query that we can execute, and there's basically only one effective way to do this. So let me, it's kind of small and hard to see, so let me turn on my actual execution plan. And when I execute a SQL statement, and then I have the execution plan tab here, one of the things that you may know, you can hover over it and it pops up and gives you a lot of information, but also you can press F4 if you want this information to kind of persist and be available for you to peruse. And then if you look over here at the select statement, over here on the right-hand side, you'll see that the optimization phase was trivial, okay? So it says SQL Server barely needed any information. The other thing about trivial plans is SQL Server's not going to put that into the plan cache. It was so easy and quick to generate this plan, I don't care if I have to do it again. I don't care if I have to do it 40,000 times a day. I can just regenerate one nearly instantaneously. There is a trace flag you can use that will force SQL Server to retain those plans in the cache, and beware. You might be running out of cache space should you ever do that. So now let's look at a similar SQL statement. In fact, it's the same one as a moment ago, except now it has a where clause. So again, same two operations. That's one of the really interesting things about SQL Server is it may explore many alternatives. It may go to another level of optimization, but it actually found a better plan in an earlier phase of optimization and just stuck with that one through it all. So again, if we look at these particular steps, we'll see that this plan is still trivial. You see it right here. Does anyone need me to turn on Zoom it for you to be able to see that? Well, okay. You raised your hand and said so. That means I have to do it now. The problem is I haven't started Zoom it yet, so let me do that real quick. Sorry about that. Should have thought of that ahead of time, right? Yeah, fire away. Yeah, so the question is, are DBCC rule-on and rule-off session specific? No. Yeah, so hijinks will ensue. Here, Yakety Sax and Benny Hill, running around and so it can be pretty crazy stuff there. So be careful. All right, so let's pull that back up again. I believe that it is now running. Let's check that. There we go. Not running well, but it is running. So there you can see it's a trivial plan right here, all right? So now, well, let's do a little bit more. We're going to go ahead and add an index on here. And what that means is before, SQL Server had no index on that particular object. And so it couldn't choose between doing, let's say, a full table scan and an index seek. So now if we execute this particular query, and let's look at the execution plan again. All right, let's see. Well, looky there. As I say I let my Tennessee accent come through there. Now that it has, SQL Server's had a couple different ways to resolve this query, it said, you know what? I'm not going to do a trivial plan because I might have multiple ways to solve this, better ways to solve this, so I'm going to go to full optimization rather than just that trivial plan. All right, now let me clean up on this, and let me show you one other thing that is kind of surprising as well, is that you can have queries that are really complex, like this particular one here. It's doing all kinds of joins across 4 tables, and yet, oops, I left something out. Yeah, I didn't get the W there on with. The monitor is just a little bit small there, so it's hard for me to see. So I've got this really big extensive query, and I used to think that, SQL Server is never going to create a trivial plan for anything that's going to query against a bunch of tables. But it turns out, no, that's not true. Let's take a look here. Yeah, it's got a trivial plan on this, even though it queried all these different tables. Does anyone want to hazard a guess of why that is? Well, I'm sorry, I couldn't catch all of that, but yes, it's because of the CTE, and remember, it resolves a view, and, sorry? Yeah. Right, so the answer is, yeah, exactly right. The response was, well, I'm only selecting from one of the tables in that CTE. CTEs are kind of ad hoc views, right? So it's only selecting from one of those tables, which means, why don't I just throw out all this other stuff right here and not even consider it? And again, if we go back to the slide, that's what we call, removal of these redundant joins and things like that. If I don't need those joins, I'll just get rid of them and not even consider it. It's another way of just saving a lot of time and energy. And here's that another trace flag you can use. This one's an interesting one. 8757, you can use this one to force SQL Server to go to a full optimization process. So when we do this, let's flip over here and look at the information, the metadata. Yeah, it's gone to full optimization, but guess what? Didn't find any better plan. So one of the things that I will be showing you is different ways you can have SQL Server go more extensively into the optimizer, but that doesn't guarantee either A, SQL Server will find alternative plans, or B, even if it finds an alternative plan, it will be better, right? Just because the optimizer spends more time doesn't guarantee that, that things will change a lot, right? All right, let me take one more look here. I'm going to jump ahead a little bit and show you, with some of this parse tree information, some of the internal memo structures. Don't get too concerned about what all the numbers are that appear and that they don't make sense at this stage. The main thing I want to show you are some of the different nomenclature that SQL Server uses in these parse trees. Okay, so make sure I've got my output turned on. And so notice I'm going to use trace flag 8605. This is going to output that initial parse tree. And when you execute these commands, you're going to find the result set in the messages. Okay? So this is that initial parse tree, and we can see it's doing a logical operation projection. And what does projection mean? Select, right? And it's telling us some columns, and if we scroll over to the right, we'll see which column names are involved in the projection. We've got state here. We'll see that it's done a few checks on things. Is this a foreign key, for example? We'll also see, by enabling some other trace flags, much, much more information. Believe me, it can get really verbose really quickly, so be careful what you wish for. It's like, well, I think I'll just turn them all on at once. It's like, wow, you are brave, because there's a lot of stuff in there. And again, what I was saying before, download this set of scripts and play with this a little bit. So here's that same statement with a where clause. And so compare them as it goes through, and you can begin to see there's new stuff in here, right, that makes sense when you think about it. Scalar operation comparison, comparison equality. And so that's this where clause right here. Where it is, where that particular column is equal to Nebraska, the code for Nebraska over here. All right? And then we can do more things. We could say, all right, now I'm going to do a where clause. Where clause is very different. It's not an equality operation. So here, that's an intrinsic like. And notice that under the intrinsic like, we have all of these different things grouped together at the same level. That means SQL Server is considering a lot of different options about how it's going to do that. That's what this means when you see one higher level thing and lots of individual things underneath it, right? So let me skip forward a little bit. Again, I don't have time to go through all of these, unfortunately. But you begin to see that there's some other interesting things that can happen inside. So there's the input memo, there's simplification, there's join collapse, there's before the full normalization and so forth, after the normalization. So let's take a look at that. And in this case, we're going to use another trace flag, 8606. So again, you've gotten just a feel for what SQL Server is using behind the scenes. Now, let's take a look at that as well. Okay, a lot more information here, and this is because it's telling us things that are happening in the parsing and binding phase that it wasn't telling us before, okay? So now, logical operation get some values on a particular table, and it tells us the table, tells us if there's an alias at play. Here's the comparison between those two tables. And let's see, was there anything else I wanted to mention there? Okay, no. So it's just showing you some more information as we go along. You can combine these together. I'm not going to do that because I want to show you some other cool stuff. Now let's add 8621. And this tells us specific optimizer rules that got applied. So now, it's the same query, but now let's take a look at that. And what's different now, as we go through the list, notice we have a whole new section here for the input tree. This is what, and then here are the rules that are applied. Remember that DBCC rule on and rule off? Now I can see specifically and exactly what rules are being applied, not just the things that were considered, okay? So it did a select join, it did a logical operation group by aggregate, and it tells you the expression it did that on. Now we see additional rules applied, simplification tree, join collapse. So what it is doing there, we would see a really, really big section if I had used that CTE query, right? Where it had all of these big joins, and it said, I don't need that. That's what would appear here in this join collapse tree, okay? And again, don't worry too much about the specific numbers of these trace flags, because there's a reference at the very end that goes through what all of these trace flags are and what they do. So rest assured that there's more in there on this. What it looks like on the final tree, this is what SQL Server will use at the very end to do, execute the query. So what's the difference between a hash match and an outer join or an inner join? What's it? Sorry? I'm sorry, I still didn't catch it. The hash match, it probes. Yes, it has a build and a probe. But more generally, the difference between saying, let's say, inner join or outer join, that's a logical. That's a logical, right. Whereas the hash is the physical way that SQL Server is going to do the logic of the join, right? Because it could say, I'm going to do a merge, or I'm going to do a nested loop. You know, I'm going to take the first value of table A and look all through table B for matches, and then the next one of table A and all through table B for, that's a nested loop join. Very, very different physically in the way it is actually done in SQL Server than a hash join, in which SQL Server takes the two columns that it's joining on and builds hashes, puts those in tempdb, and compares the hashes together. So a hash join, typically going to be used for really, really huge tables where I've got to look at 3 million records versus, on one side and 8 million records on the other side. So it's going to take too long for me to loop through all of one and then the next and then the next and loop through like that. I'm going to use this physical method that is much, much faster. All right, let me show you a little bit more about simplification. So here I'm just going to pull the estimated plan on this particular one. And boy, oh boy, I sure hope I can see that button for estimated plan. Okay. And again, I can't even see this stuff from here. So here we have the particular steps of this particular SQL statement. Notice it's got an inner join and it's got a hash match here, okay? But SQL Server will do all kinds of things to simplify. And so we can see what SQL Server is doing to simplify with our different trace flags here. 8606 here. And when we look at the results, we're going to see the converted tree, we're going to see the input tree as before, we're going to see that simplification tree. So these are the things that SQL Server is, maybe it's doing predicate pushdown, or maybe it's doing different comparisons and is choosing between ways to do these things, and on it goes. Is everyone familiar with the concept of predicate pushdown? Does anyone need that explained? Oh, a few of us are. Okay. Let me see. I'm not sure if I actually set this specific example up perfectly for this, but what happens is we get that estimated plan. Well, if this was a bit more complex of a plan, let's say, for example, we had another step here for, let's say a compute operation here. Maybe there was an alias, and so it had to transform a particular column name into another name. what happens to the execution plan if that compute function appears here versus pushing it down onto a lower level of the branch? That's what a predicate pushdown is. And so SQL Server will try that sort of thing very early in that simplification process. Hasn't even gotten to the actual statistics and the data inside of the table, and it'll push that down to see if that gives it a better plan and a better alternative. Contradiction detection happens at this phase as well, and this is a really interesting concept. What if I have a query that just can't return any results, where the unit price is greater than 50 and the unit price is less than 25? That's a contradiction, right? So again, I get 0 results returned, and if we look at that, I'll just grab the estimated execution plan. It says, yeah, I do a scan for all of this, but I know I'm not going to return any rows, so I'm done. Same kind of thing happens. Believe it or not, one of the biggest performance gains you can get in certain kind of design scenarios is to simply make sure that you have declared all your foreign keys, and you have put non-clustered index on those foreign keys. But you get that performance advantage only when both of them have been put onto that column. And that's because SQL Server now knows, logically speaking, that it is possible that contradictions exist for that foreign key, because your foreign key says, I have values in this table that are on the primary key of this table, another table over here. And so we'll look at those and say, oh, you know what? I can see that the way this is declared is causing a contradiction, and so I don't have to do that work at all. I'll have an execution plan that says, a full scan like it does here, constant scan, but I'm actually not executing anything because I know there's a contradiction. So again, if we execute this particular query, and I always miss that first letter there. I need to start at the semicolon and go from here. So here's our result set. Let's look at let's look at the actual plan since I went ahead and pulled that. Right? So we've got the clustered index scan. Is that what I'm seeing? Yeah, now let's actually take out the foreign key constraint. Now let's get the estimated, sorry about that flashing there. Let's get that estimated plan again. Notice how much more complex it is. We didn't take away the index. We only took away the foreign key. Yes?
I believe it also affects your joint elimination.
And that's correct. It also affects the joint elimination, right? The joint simplification process. Because now it says, okay, you are joining on two search argument columns, but I don't know there's a foreign key relationship, so I'm not sure I want to compress on that because I'm not sure that there's a foreign key constraint here. So now, it makes entirely different choices based on whether that, whoops, that was not a good one, good call, based on whether that foreign key exists or not. So again, interesting stuff. Let's go ahead and alter the table, add that. And unfortunately, I don't have enough time to go through this whole process, but SQL Server will even keep track of, did you drop the key? Okay, I'm going to give you one execution plan. Now you added the key back, but if you didn't check the values, I might have contradictions in there now that violate the foreign key. So you could have execution plans that again say, oh, I'm not going to really give you the results you think you're going to get because we may have violated that key. And so hijinks ensue. I like to use that term. All right, so let's move on. I need to make some time here. All right, so we've just gotten through binding, simplification, trivial plans. Now, and I talked about simplification. Here are a couple of the trace flags that I showed in the demo there. Now, let me tell you a little bit about some additional telemetry. And in order to keep, ensure that we meet our time limit, and we only have 20 minutes left, let me actually show you these in aggregate, okay? So these are some really cool queries, or DMVs that you can query that will give you tons of additional information about how SQL Server is doing your processing. We've got DM exec query info, And I have a reference in here for you. The intention is not for you to be able to read this, but to actually open the file later on and read through this. I'll zoom in. Whoops, I'm on my wrong monitor. So you can see what these different query optimization steps are and so forth, what it means in the particulars of that DMV. And I'm going to actually go ahead and go to demo and show you a few of these at one time. There are 3 different sets of telemetry that are not DBCC statements that I have in this separate file that is, it's called the query telemetry. And so the first thing is this DM exec query optimizer. So when we execute that, we get all sorts of information here about the, whoops, that's strange. It's not going over to this left-hand side of the query here. Nope, it doesn't like it. Sorry about that. What it's showing you is all the different steps that it has done in aggregate. Remember, with DMVs, it's in aggregate since the last time the server was started. So it's telling us things like the number of trivial plans, the number of queries it's gone through to search phase 0, search phase 1, search phase 2. And so this tells us, you know, what's going on in the broader sense of the optimizer doing its work. You can also do some clever things on this DMV. For example, I could say, I want to find out how many of my queries, just as a percentage, have hints in them, right? So in this particular example, you would just go across all the optimizations that have hints. And we see on my little demo box where I don't have any real workload going, I've got 0 at this point. But in your production server, you might have a lot. And this can also be really informative if you bought packaged products. Because I'll tell you, they'll advertise that this is you know, a really well-written app. But if you start looking at their code, you will see that it is a really crap app. You know, a lot of times they are not good. The second telemetry DMV I wanted to share with you is around some X events here, okay? And this particular one is, this particular example shows all of the different extended event optimizer parsed, whoops, I did it again. So this is everything that in a extended event session it might refer to for that particular query optimizer tree. So you can query this DMV here without a where clause and even see more information about it. The exec query stats is another DMV that many of us don't know about. And this reference here tells us all of those internally, academically named operations that are happening behind the scenes. At the very end of this example set, here's the extended events that I was telling you about, by the way. For example, this one, we could see what the cardinality estimates are. But on the DMVs, there's also some sample code further on at the bottom that walks you through doing snapshotting, right? So take a snapshot of that DMV, execute your query, and assuming that not much else is going on, take a look at it after you've run your query to see which of the different optimizations have, you know, or incremented up a number or two, so that you can see what it was doing in aggregate. Now, don't forget when you do that, though, that if you have the system doing anything else, those are going to be counted too. So if you've got SQL agent enabled and it executes a job, all of those values will show up in there. But assuming that you're aware that that's the case, you can get some really good information on what your SQL statements or statement is doing at the time, and it can help you determine, you know, what is happening there. Can you clear these DMVs? The short answer is no, I don't think so. At least when I was doing my research, it did not look like that was true. The longer answer is maybe you can. There is a DBC statement called, yes, SQL perf. And so you could say SQL perf clear, and then you name a specific DMV like OS performance counters. I haven't tested it myself, so I bet probably in SQL 2016 or 2017 you can, but in 2014 you can't, okay? So there's a short answer and a longer answer. Now, Let's dive into the stuff you probably wanted me to spend all this time on, the really deep optimizer steps, right? So what most of us want to talk about are the big hard queries that spend all their time on this. And so one of the things that's really interesting about optimization is that it uses this cost-based optimizer, and it has these values in there when you start to look at the results of these DBCC statements, and it'll say a cost on a particular step. Or if you look at the execution plan and you hover over in the graphic execution plan, it'll show you a cost. Where do those numbers come from? Well, they actually, the rumor is the SQL Server internals, the manager for the optimization and logical processing was a person named Lubor Kohler for many years. And Lubor tells the story about how a developer named Nick, and here's a picture of Nick's computer, by the way, at that time. He went through and he ran all these different commands, and he had like a stopwatch out to see how long it took. And so, you know, if the hash join took 3 times as much time as the nested loop join for this particular one, he penciled down what that number was, and that's how the initial numbers were created, right? Keep in mind, if you are comparing those values, the cost of the first part of a query to a later part of a query, those are all going to be synced up with one another and meaningful. But if you compare query version A to query version B, and it says that step 2 costs 3, and step 2 over here also costs 3, they may not be equal. It only has context within the individual statement that you're executing and testing, okay? All right, so let me make some time here. We talked about simplification trivial plans. There's 3 more steps after this, and these are the steps that actually require that the statistics get loaded up. The statistics and the histograms. There's phase 0, which produces transactional plans, and SQL Server is looking for a quick match of the pattern here. It's looking to say, okay, you got 1 through 3 tables, possibly 1 through 3 joins. Okay, transactional plan. I know exactly how I'm going to process you. And I don't want to go further. I want to give you an answer as fast as I can. Phase 1 is what it calls a quick plan. And this has some, opens up some new rules. There's a new cost threshold, which basically amounts to a certain amount of time it's going to give you. And so, like, for example, with a quick plan, SQL Server knows that if it better not have more than, say, a certain number, I think it's like 7 or 8 tables involved in it, right? And then if it's more than that, I have to go to the next phase. I have to go to phase 2 for a full plan. And when I'm doing things in a full plan, I'm probably going to fully parallelize the query. I'm going to consider different kinds of ways of putting temporary work sets into TempDB, either by spools or spills. All kinds of things are going to happen then when we get to that full plan level. Now, the difference between one big difference, as I mentioned, with phase 0, but phase 0 and phase 1, SQL Server is looking to match the shape of the query. 3 or less tables, between 4 and 8 tables. Okay, I got a quick match. What's different about phase 0 is SQL Server now knows that it can't really do a specific match because there's too much, there's too many choices. So instead what it's going to try to do is it's going to try to do something called pruning. So it says, I've got 7,000 heuristics in the query tuning engine. What I want to do now is I want to cut off entire branches of investigation because I could be here all day trying to figure out the best execution plan. So you know what? I know that this server doesn't have more than 4 CPUs, so I'm not going to really spend a whole lot. I'll look at parallelism a little bit, but because I know I don't have that many CPUs, I'm not going to spend a lot of time on that. So it's looking for opportunities to cut off and prune branches of the investigation to get that result set very, very quickly. I like to say that SQL Server is going to give you not necessarily a good plan. SQL Server wants to give you a good enough plan, right? And it's kind of the difference between optimal and best. SQL Server wants to give you an optimal plan. How's that different from best? The best plan might take a day and a half to figure that out. So consider in a 4-table query in which we have 3 joins here. SQL Server is going to consider all kinds of different physical access methods. So that's the different joins we could do. You know, we could do a merge, a nested loop, or a hash. We're going to look at, maybe we could do an unordered clustered index scan. We could do a unordered non-clustered index scan that is covering. We could have clustered seeks. We could have, you know, partial range scan. We could have, you know, we could use index intersection. We've got lots of different options physically for what we're going to do. But that's only the beginning, because we also have the ability to manipulate the join order. And it can make a really, really big difference in the execution plan if I start by joining table A to table B, instead of going with table B to table C, and then later joining A to the result set of the join of B and C, if that makes any sense. So we could have a really bushy plan where it's looking at all these different joins, or we could have a very linear plan where first it looks at A to B, and then it looks at B to C, and then it looks at C to D, like that. So that's called a linear plan, as opposed to a bushy plan where it looks at all the different joins together. It's kind of the same sort of level. Now, what do you get in a situation like that? Just on a 4-table join, no where clause, no group by, SQL Server's got almost 26,000 alternatives to consider. Whoa. Like I was saying earlier, I'm surprised SQL Server even gives us a result set sometimes, you know? But it manages to do it well, most of the time. This is why it doesn't give you the best plan, though, right? The difference in time it takes to figure out, do I go with A or B? One of those is pretty fast, and the difference isn't that great, so I'm not going to spend time looking at every single alternative. As soon as I find a good enough plan, why the heck don't we already go that? So now, let's look at these other 3, and I'll tell you, some of the things that we're going to see in here are what we call transformations. This is the most common thing that SQL Server is going to do behind the scenes. It's going to do things like a commutative join. So it'll go through and it'll flip and it'll flop on the different joins. It could do join table A to table B. But it might be better if we go from table B to A, because table B has much less records. And so if we filter on table B first and then join that to table A, we wind up having so much less work to do. So that's called an exploration transformation. Another one is the implementation transformation, and that's where I was talking about hash join versus a merge join. That might be something like, maybe I spill to tempdb using either an eager spool or a lazy spool. That's the physical way I'm doing it. And so that's what an implementation transformation is. And then finally, another form of transformation is a physical property enforcement transformation. So that's where I do something like a uniqueness constraint can help me change around this particular query so that I get a faster, better performing execution plan. Now, one of the things that's interesting about all of these different transformations that SQL Server is doing behind the scenes is that as it goes through that process, it is building out these costs for all these different steps. And so let me actually show you that as well. Let's go over here to a demo. And this is where we might have to go over, folks. I'm sorry. I know your brain is already ready for the day to end. All right. So let me show you some things inside of this as it goes through these different transformations and such, okay? So the first time I wrote this hint, I forgot to put 2 S's there. So really, really changed the whole context of this. So we've got an execution plan. We're just doing a simple lookup, the customer ID with account. But here's the thing. Customer ID, what do you think? It's kind of unique. So it would be weird for us to have a lot of count. Okay, so how many customers do we have in that particular region, right? So, sorry, I've got a phone that's distracting me. So when we look at the, oh, did I run my I thought I ran my trace on. Oh, I'm sorry, I was just showing you the execution plan. So let's look at that execution plan one more time. My bad. And so we see there's a merge join, okay? And as we go through, again with that F4, you can turn it on or off. You can see the information on pop-up, or you can see it over here on the right-hand side. Notice it says rewinds and rebinds here. We're going to see that in the metadata in just a moment when we look at these internal trace flags. Now, let's take a look at that logical parse tree. We're going to see this is just the logical stuff, hasn't done any of the physical operations yet. And so we'll see all of those different steps. Since it's all logical, though, it's not showing us any of those physical costing. So let's skip ahead and look at some of that physical costing here. I'll go to the final memo. And this is one of the trace flags I use most often. 8615 or 8675 are the ones that I use most often. So when we look at this, when we look in the memo, we begin to see these things. We see here's a group, and underneath that group is one operation. If we see 2 or 3 or 4 operations, that's telling us that SQL Server considered 2 or 3 alternatives there. This number here is telling us the other groups that relate to this specific operation. So actually, number 37 and group number 6, if we scroll way down, see here's one that has multiple choices it could choose between, and it's got the number of rewinds right here is pretty high. The number of rebinds here is pretty high. And so it's telling us what the cost here is for each of these. This particular cost is 0.21 blah blah. This one is 0.31 point blah blah. So this tells you why it did not choose to do this one as opposed to this one. Okay? And then if we scroll down to number 6, we'll see exactly what was going on at that step that contributed above. Okay? Total distance, the distance number is important because this is telling us what level, what phase of the search heuristics that it's going through. So it really didn't have to go deep to get this kind of information. All right? Now, here's a nice little summary, is 8675. It's similar to 8615, but this one gives us summary information in the memo structure. So here it's telling us, yes, it went to search phase 1. This is the best cost it found at that time. The number of tasks is the number of operations that it considered. And we see that it stopped there. Didn't go any further than that. Okay? If we look at another trace flag 2372, this one is also another summary, but it also gives us a little bit different information here. This is telling us the amount of memory that's consumed on each step and the exact phases of the execution process or the query optimization process it's gone through. Quick plan is equal to search phase 1. Okay? Now let me jump over and show you another slide because I'm almost out of time and there's a couple slides I want to show you. Is about the memo structure. I showed you lots of information. It's like, what the heck does all that mean, right? So here's how you read it. So again, you know, in passing a moment ago, I showed you this kind of information in the memo structure. This is telling you, first of all, that 0 is telling us the entry number, and it's all zeros here because this is all logical, okay? Then we have the logical operation, which I took probably a little bit too much time to explain how to figure out what all of those are. This is the group number. So this is group number 13, but what this is telling us is that this has 2 child groups, number 8 and 9. So here's number 9, here's number 8. Those are 2 child inputs that help build up this particular step. And then it is defined by the subtree on number 12 here, which it has its own input steps. Notice this number right here, or this bit of information. What does that mean? Card? Thank you for reading ahead. That means the cardinality estimate. This is why keeping up with your statistics is so important. If that number is wrong, every bit of the costing will be wrong from then on out. So this is the internal, initial memory structure. That's at the logical phase. Then we have the final memo structure. This is as SQL Server has gone all the way to that final physical choice between, a hash join and a merge or what have you. So to read this is a little bit different. Again, we have cardinality. Here are the logical operations because it's telling you logical operation join. Remember, here's those subquery or the child groups of it. And then up here, this is the new thing that we didn't have before because in the logical phase, we don't have the costing step. But here, we do have all the costing. It's looking at the roll goal, which is the number it chooses to try and figure out how much memory it needs to give in a memory grant here. Then we have the number of rewinds, rebinds, the distribution of values, and then the cost number itself. If you want to look in the slides, I actually have some information in the slides that tells you exactly how SQL Server calculates the value for all those costs. But believe me, it's for math majors. It's not the kind of thing that we would use in our daily life, okay? So here's the last thing I promised. One of the things that I always wanted in SQL Server, I know SQL Server well. And one of the things I know about this, particular workset A, as opposed to workset B. Workset A isn't one in which I have people doing a lot of ad hoc queries. There's not an impatient person sitting there waiting for a result set. So I don't want SQL Server to worry about taking a lot of time to build the very best execution plan it can. Because this is a reporting system, and these reports are called 20,000 times a day. And even if I only save 7 or 8 or 12 cycles, I want you to do that because no person is getting judgmental and rushed. But the system could give me a better plan if it had more time. And the way you can do that is with this trace flag 8780. It's pretty cool. Now, I'm going to show you an example of this, not in Management Studio, but instead I'm going to show you in Plan Explorer, which is a product from my company, Century One. And I hope you use it, but if you don't, that's fine because you just want to work harder. Oh my gosh. So let me bring that back over here. Yeah, so this product is completely free. It is so free that we don't even ask for an email address. So, you don't have to worry about being called by salespeople or anything like that. And we just want people to use it and take advantage of it and enjoy it. So here, what I'm looking at is I'm looking at a SQL statement that I have executed over time. And again, I apologize that this is so tiny. Gosh, and I can't grab that. There we go. If I look at the command here, what I see is this is a really big SQL statement. If you count up the number of joins, it's like 9 or 10 joins. I'll tell you right now, don't even bother to use trace flag 8780 unless your query has at least 5 joins. It won't find anything better. When I say that, not to say that there isn't something better, it's just that SQL Server is so good at working with queries that size, it's good, right? It's when it gets really, really complex that this query trace flag can really help a lot. So you see 1, 2, 3, 4, 5, 6, 7, 8, and there's 10 or more joins here. So what I want to show you is that I have 2 versions of this query. And I'll turn on the history in Plan Explorer. So here's version, let me see which version. Okay, so this version right here is the version of the plan before I put on trace flag 8780. And if we go over here and look at the history, we can see that this version ran in 1.9 seconds or thereabout, right? Then I told SQL Server, you know what? Let's go ahead and run this with 8780. And first of all, you can see that the execution plan has changed up a little bit. For one thing, there's a lot less of these red indicators that you've got a problem. It does bunch up and create more records at these intermediate joins throughout. But down here at the bottom, you can also see that over time, if I replay this query, you can see it does this little marching ants, and you can see the different places that the workload is hitting in terms of CPU, I/O, the different weight statistics. you can see that these hit in different places than the original version that doesn't have trace flag 8780. So again, I'll flip back. Here it is without 8780. See, it has, even if you can't see exactly what these trace flags are, these weight stats are, you can see they're different colors. So that means they're entirely different categories of weight statistics. Here it is with 8780. And so these are all, it looks like SOS scheduler yield weights, whereas the other version of it had primarily IO weights. And so you can see that it has produced a significantly different execution plan. It's not guaranteed to find additional execution plans, and it's not guaranteed that ones that it finds are better. But in plenty of cases, it will find a better execution plan. So what do you do then? Let's say you're query tuning on a packaged product or something that the dev team has built, and you see that there is a better execution plan than we normally get. What most people would typically do is they would create a plan guide for plan substitution. And they'd say, anytime you see this other version of a query run, and let's say it's a vendor application where you're not allowed to change the code, with plan substitution, you could say, when you see this poor performing version, use my version instead. And now I go from 1.8 seconds or 1.8 hours to 0.52 hours, right? And so you get that much better performance on internally. Anyone learned about this trace flag for the first time? Oh, right on. Okay, good. So the extra 6 minutes that we spent on this, I hope, was worth your time, okay? Now again, if it doesn't give you better performance, I warned you, okay? So don't use this as a blanket sort of way to try and improve performance. Absolutely not. You need to do regular query tuning if you can. But if all else fails and you're working with a vendor who will not allow you to touch any code, this, if nothing else, can sometimes give you better performance. Okay, just to wrap up now, we're in the final stretch. And again, sorry about the delays here. The trace flag reference that I mentioned at the very end talks about all the trace flags that are in the scripts. So just to make sure that you have all of those. One I really wanted to show you that's pretty cool that a lot of people haven't seen is trace flag 9292 and 9204, which actually shows you exactly what statistics it's using to calculate these different execution plans. So these are, and this one, unlike the others, the 8615, 8675, this is kind of makes sense. So it doesn't need a lot of explanation or anything like that. But these are also undocumented trace flags that don't tell you too much about, there's not a lot of documentation on those. The command reference, these are the main commands that we use throughout. These are some of the dynamic management views you want to get to know and get familiar with. And so with that, I'm going to go ahead and throw up the summary slides here. One thing that is, I hope you might take advantage of that we have done for the very first time. If you want these slides and these scripts right now, if you pull out your cell phone and text Kevin to 797979, it will send you a link. We do not track your cell phone number, so don't worry about that. There is a little gateway that says, tell us your name and that sort of stuff. And then you'll get access to this stuff right now, as well as probably the last 8 or 9 other presentations I've done in the last few months. So if you want access to this stuff right now, go ahead and grab it. Text Kevin to 797979. If you want to get it from the past website, of course, feel free to wait for them to get that posted up there. So with that, gosh, folks, I'm sorry I went about 8 minutes over. I hope it was valuable and useful information. Please play with those scripts. Give me your feedback. Let me know what you think. Don't forget to evaluate, put in the evaluations, and have a good conference. Thank you, everyone.